Hello everyone, my name is Kingsley Idoko and I want to welcome you to another session of our video. In this section, we want to continue from where we stopped on automatic failover. So in a previous video, we tested manual failover and now we also started the automatic failover, right? Automatic failover. Okay, so in the automatic failover, in the previous video, what we did was that we did a recycle of this device and we had a detailed review of how the secondary transition, right, from secondary to secondary hold to primary, So if you missed that part of the video, you want to go back and then have a look at that. But what we also want to do now is we want to continue the automatic failover, but now we want to use the interfaces. Okay, we talked about the interfaces in the past, that what happens if this interface goes down. Maybe it could be a cable issue or the SFP is bad, but it goes down, right? And we said by default it's not going to affect the cluster, and there's the cluster, they're still going to see each other, and so you will not have like a automatic failover. But we said that if you are monitoring the interface, which is the interface monitoring, right? So when you monitor the interface and then this port goes down, then that's when you can initiate an automatic failover from the primary to the secondary. And in this our topology, this is our primary and this is the secondary, which is really node 0 and node 1. Okay, so that's what we will test in this section. And then we also look at there's also an aspect that we've also not tested, which is the preempt. The preempt delay. I think we tested preempt delay though, but what we have not seen is the preempt limit. Okay, and the preempt period. Okay, so the question is, this port goes down, the traffic failover to the secondary, right? The port comes back up and then the traffic moves back. Okay, so you have like two failovers now, right? And then the traffic moves down again, right? Because this port is continuously going up and down. Okay, now although there's the hold down timer that kind of dampen what the the rate at which you have failover, but in the end, once the hold down timer expires, what do you have? You're still going to have traffic going back and forth. Okay, and we said that's the reason why you have this limit count. So we are going to say that if you have 3 failovers within, we can say, okay, within 10 minutes. Okay, so if we have 3 failovers, right, from primary to secondary within 10 minutes, right, so that's the period. The value is actually not 10 minutes, so 10 minutes I think 10 minutes will translate to like 600 seconds. Okay, so we're going to say 600 seconds to translate to 10 minutes, and then we'll say if you have 3 failover, it means something is really wrong, and so you can't continue to have traffic go back and forth between those nodes, otherwise it's going to impact your service. So we're going to see if we can simulate this, where we're just going to go to this interface, shut it down, bring it up, shut it down, bring it up, until there's a match here. Okay, now something else you need to understand is, so the interval here is, let me look for a place, let me just erase everything. So the interval here we said is what? 600 seconds, right? Which is the period. And we say if you have 3 failovers. Now what happens if you hit the 600 seconds, which is the interval, and your failover is just 2? Okay, so you hit your 10 minutes, but failover is just 2. Now this there's a countdown from 600 seconds down to 0, right? So this interval is over, it starts all over again. It starts from 600 again, right? Now what happened to this value? This failover of 2 is also going to get reset. Okay, so you're going to start back from maybe 0, right, to 1, to 2, to 3. Okay, So what the point I'm trying to make is this failover count applies to this period, right? So it's not like when the period resets, the failover count still keeps going. No, that's not what happens. So whenever there's a reset of this, then this too is you're going to have a reset. So if you're having failover but it's not too intense and within the threshold you are not hitting the limit, then you might not you could continue to, you could have continuously have this failover going on, between both the devices. Okay. um in our case, these interfaces are all in redundancy group 1. So the failover we really want to test is for redundancy group 1, because that's where we put our interfaces. Okay, but if these interfaces were in redundancy group 0, then it means if there's a flap here, it could cause automatic failover. I think so. I think it should cause automatic failover, because it's going to set, remember, okay, so let's even talk about the interface monitoring now. Now, each redundancy group has a weight value, right? So each redundancy group has a weight value of 255. Similarly, for redundancy group 0, it has a weight of 255. Okay? So what happened is we're going to take this interface. We're going to say your weight value is 255. We'll take this, say your weight value is 255. Same thing here, 255, 255. Right? So what happened is if this interface fails, we are going to take this value and we're going to minus it from the redundancy. Remember, this is 1. Okay? So we're going to take this value, minus it from they call it tolerance. I think the word they call it is tolerance weight threshold. Okay? So we're going to take this value and minus it from this tolerance weight value, which is the global value for the redundancy group. And so when this value becomes 0, then that's where you have the failover. So when you have one interface, yes, you can set the value to 255. So once it goes down, you take this 255, minus it from the tolerance weight value, and then you get 0. So once it's 0, then there will be a failover for that redundancy group 1. Now the other question is, what if when you have two interfaces here? Okay, so let's say you have two interfaces and the rect 1 here. Okay, you can as well set this interface as 255. Okay, but what is the implication? Okay, so let's say you have the same thing here. Okay, so we said here is 255, then we also set here as 255. You can also set the values at 255, but the implication is that if one port goes down, one of the interface goes down, it's going to take this value and minus it. Okay, so it means a single port here, if it goes down, you are going to still have failover, even when traffic can go through the second link. But if you want to avoid that, then you might want to break the values down. Okay, so you can say, let me do some erasing here. So what you can say is, okay, I want to put here as 130, and then maybe here as maybe 125. Okay, something like that. Okay, so what that means is, if this port goes down, we're only minusing 130 from the 255. Okay, and of course, whatever value it gives you here, which is so this is going to be 3 from 5 will give you what? 5, right? And then you have, which is 155, I think. I hope my mathematics is correct. Okay, so this value is not 0, right? No, this is not 5, this is 2, 125. Okay, so this value is not 0. So long this value is not 0, you're not going to have a failover. Okay, you're not going to have a failover. It's only when the threshold is 0, that's when you are going to have a failover. So now it depends on the use case, it depends on the scenario. So if we have let's say these links are 10 gig links, okay, and the traffic to these servers is maybe 14 gig, right? It means you cannot afford to have one interface go down, right? So it therefore means you are going to set weight values that, so you're going to put the weight value as 255, in a sense that if any of the port goes down, then you definitely want to move your traffic out of that device. Okay, but if your traffic is below 10 gig, even if one port is up, you can still, yeah. So that's really what we need to know about interface monitoring. Now, for redundancy group 0, let's say if these ports were part of redundancy group 0, let's say this one link, they were all part of the redundancy group 0. It therefore means if this port flaps, you could have, traffic move between the primary to the secondary. Okay, so in most cases, you don't want to have these interfaces in redundancy group 0. You want to use different redundancy group. Okay, you have to move it away from redundancy group 0, because if this flaps and redundancy group 0 moves, what you are essentially moving is the routing engine, right? Routing engine stops here, and then you are spanning on. So you are going to have tremendous impact on your traffic. So that's why it's really not advisable to put this physical ports, this data port on redundancy group 0. And another thing is, when there's a failover, let's say this interface is in redundancy group 0 and there's a failover from node 0 to node 1, what happens is this node for 30 seconds, okay, is going to disable monitoring for all its interfaces. Okay, so if it disable monitoring for all its interfaces for 30 seconds, that will prevent other redundancy group, let's say 1, 2, and 3, from also failing over to the secondary. Okay, so it's just some kind of built-in mechanism by that Juniper implemented for that. But in most cases, you will not want to put your physical interfaces in a redundancy group 0. Okay. Yeah, so I think we've talked about everything that we need to see. So what we now need to do is we just configure, right? So we do the configuration, we add these interfaces to monitoring, okay? And then we can just come here and then we try to shut down and see if you have a failover. Okay, so that's just what we need to do. And yeah. So let me bring up as usual, our continuous ping is running through from the servers, so the servers can reach the internet. It has always been that way. So what we need to do now is do the configuration. So let's make it a little bit smaller. Move this here so we can be seeing the topology a little bit. Okay, so the command is very simple. It's hit my edit. So it's set chassis cluster. So it's on redundancy group 1, right? Redundancy group 1, because that's where those interfaces are. And then we just say interface monitor. Okay, interface monitor. And so when you say interface monitor, it's going to ask you which interface. So in that case, it's going to be GE 0/4. Now let me show you the physical port here. Another question is, so I hope you are able to see it. It's very big. So these are the ports. So here we want to, so this is for the LAN on both ends, okay? And this is the wide area links, okay? Another question, I've not really tested this, so I don't know. Can you instead specify the rect interface? I really don't think it's going to work, because rect interface does not apply to a single node. It applies to both nodes. So when you say you want to monitor the rect interface, maybe it goes ahead and monitor the physical interface inside the rect interface. I really don't know. But in most typical cases, you're just going to be monitoring the physical port, because the physical port is unique between the nodes. So we know exactly what we are monitoring. But when you are monitoring the rect interface, we are going to check if it's going to even take the command. You are not being specific on what you are monitoring. And besides, if you tie the weight value to the rect interface, probably it's going to be inherited by the physical interface. Maybe I'll have to check Juniper documentation if it's explained there. But what we're going to do on our end is we're just going to monitor the physical interface. Okay, so we've agreed that it's port 4 and 3 on both sides. Those are the ports we need to monitor. So let's do that. So I'm going to say GE00/4. Then we say the weight. Now I'm really not sitting properly on my laptop. The weight is 255, because we really have one interface there. Then the second one is going to be on the other end. You know the offset is 7, so that's the port there. And the one link is also port 3 on the other side, on also port 3 on node 0. Okay, so those are the ports. So I'm going to say show pipe compare. Yeah, so these are the ports. We set the weight. The global weight value is already tied to the redundancy group. You don't have to configure it. So we only have to tie the weight to the physical ports. So I'm going to say commit check. Cool. Okay, and then we can hit commit. So it's there now. So we are monitoring the interface. One way we can confirm, let me just expand this now, is to say show chassis cluster status. So node 0 is still the primary for redundancy group 1. We can say show chassis cluster interfaces. So if you go down, now you see that those interfaces are now being monitored. Okay, so these are the weight values, these are the ports that we're monitoring. They all belong to redundancy group 1, and the status is physically up and they are being monitored. Okay, so it's pretty straightforward. Okay, yeah, so what we can do now is we are going to try to shut a port down and see if you have a automatic failover. Okay, that's what we need to do now here. So if you do the up arrow key again, we see status. So here we see that node 0 is currently primary and node 1 is the secondary for redundancy group 1. Okay, so I'm just going to come here now and we shut one of those ports down. So this is the port I want to shut down, which is on the primary. It should force traffic to move to the secondary. Now, before we do that, let's be sure what the value is for our hold down timer. So I'm going to say show configuration pipe match. Just say hold. See if there's anything. See display sets. So I don't think we have the hold down timer configured. Yeah, so it's not configured here. If it was configured, you see somewhere around here. These are preempt. So we're going to also test this, just like I said in the beginning. But I want to, so if you don't set it, I think, you know, for redundancy group 1, the value is 1 second, right? But we can just set it. You can say set chassis cluster redundancy group 1, hold down interval is 1 second. Okay, commit and quit. And so now we can say set interface GE0/0/4. We're going to say disable. Okay, we're going to hit commit. So we are shutting port 4 down. In the real world, you probably just pull the cable and see what happens. Or you shut it down on the switch side. It's still going to be the same. But in EVNG, even when you shut it down on the switch, it's going to be up. Even when you remove the connection, it's still going to be up. So the best way to do it is to, so if I say show chassis cluster status, we have to use the run command here. So as you can see, there was a failover, right? So our failover count now is, I think the default is 1. It starts from 1, I think. So our failover is 2, right? You see this flag here that say IF, I think tells you that the interface is being monitored. So there's a failover from node 0 to 1, so it should come back up. Okay, I expect this. Okay, so it looks like it automatically sets the priority to 0, right? Yeah, that's what it's doing. It's also set the priority to 0 manually. So let's bring back the port again and say, so we're just going to do the up arrow key and say delete. So I'm going to come here and say delete. Okay, commit. Okay, so if you do this again, then it should fail back to So once the hold on timer expires, you see it's going to primary preempt hold. Don't forget that what that does. Okay, so it's transition back to primary because we brought the port up. So we are going to shut it down again just to test it the second time. Bring it back up, commit. So this is, so the failover count now is 3. So we keep doing it. So we should definitely get to a point. So let's do show chassis cluster. So you should move back to node 1. So we need to bring the port back up, right? So let's bring it back up, commit. So it depends on when the interval starts, because the interval is always running from 1 to 10 minutes. So if we are able to have, so what I'm saying is, where's the configuration that I should then? It's too far from the top. Run show configuration pipe display sets. So this is what we want to test now. We are saying if within 10 minutes you have 3 failover count, right? Then it should stop the failover. The automatic failover is going to be disabled, or the preempt, okay? It's going to be shut down. So that's what we are trying to see if we can achieve that. So if I say delete not found, so it means that port is already up. So shown. So it's back to the node 0, which is the primary. Okay. So let's shut it down again. Shut down, commit. Let's see again. So it has moved back to node 1. Let's bring it back up. Commit. Okay, let's see. So it's still not there. Let's see if so if it doesn't move back, so it's still moving back, so it means we've not reached the limit. Okay, let's do it again one more time. Commit. So I think it really depends on the interval. Maybe we've exceeded the 10 minutes, and so everything is, the reset is back to 0, right? So we've shut it down again. It should move back to node 1. Let's bring it back up again with this delete, and then commit. Let's see. Now it hasn't moved. It refused to move, exactly. Okay, so with the way it is now, it should have moved back to node 0. Okay, but it has hit that limit. Okay, so there's no, the failover is disabled for redundancy group 1 now, because the system has seen that, oh, something is obviously wrong with that port. The port keeps coming up and down, coming up and down. Once I go back to node, once I hit that the limit count of 3, right, then you have to disable. Okay, now another thing I'm thinking in my mind is, so when you fail over from node 0 to node 1, that's one failover, right? But that one failover applies to node 0, I mean. Okay, so when you move from node 0 to node 1, and from node 1 to node 0, it's actually the count here is that it's 2. But I think from the device standpoint, it's actually like 1, okay? Because how many times do I fail over to you, and how many times do you fail over to me? So since we are having 8 here, it's probably 3 on both sides. Okay, that's just my thought. I don't know, because what we actually, you know, what we did in our configuration, if you look at it, we say run show configuration pipe display set. You see what we set is 3 actually. So you have 1, so you already have 1 by default, so it's 2, 3, 4. Okay, on both sides. That's just my thought. I don't know if it's true. Okay, but at least we know that, oh, that preempt limit actually kicked in, and so the failover was paused. Okay. Now, before we wrap up from here, I want to quickly talk about the disabled state and the ineligible state. Let's see if we can simulate that here. Yeah, it should be possible. Let's go back to the topology. Yeah, so now we said what happens if there's a failure on the control link. Okay, so we have what we call the ineligible state. Okay, so we have what we call the ineligible state. Then we also have what we call the disabled state. Okay, then of course you have your primary, which we are aware, and the secondary state. Okay, so these are different states that a node can exist in. Okay, now the ineligible state occurs when there's a problem in the control link. Okay, the service processing unit, right? I think in newer from their documentation, I think which is almost like the routing engine itself, right? Or I think previously it was the Juniper service routing redundancy protocol. Either one of these is actually responsible for sending heartbeats over this control link. Okay, and we said the heartbeat is what? 1000 milliseconds, right? Per what? We said for every 1 second, right? So 1 second is equivalent to 1000 milliseconds, and so the threshold is what? 3 seconds, right? So what we are saying is, if the heartbeat, so it's 3 seconds, right? Which is like 3 counts actually. Okay, so we are saying if you don't get heartbeat for 3 seconds, okay, from either of the device, they are going to declare the other neighbor as either lost or they move to ineligible state. So what happens is, if this link is broken, so when this link is broken, it means node 0 is not able to send heartbeat to node 1. Similarly, node 1 is not able to send heartbeat to node 0. But remember, this is primary and this is secondary. So what will happen is, primary will remain primary, but the secondary will transition to what we call the ineligible state. Okay, it's going to say somehow, I don't know, something is probably wrong, right? Now, the reason why it transitions to ineligible state is that this same process, either one of them, will still try to send heartbeat over the fabric link. Now, if they send heartbeat over the fabric link and they are receiving heartbeat, right, over the fabric link, that tells these two devices that the control link is actually down. That's when they transition into these two states. Okay, if this is broken and this is broken, they are both lost and they both transition to primary. But if the fabric link is still up and they are receiving heartbeat over this fabric link, then they transition into this ineligible state. Now, once they transition into this ineligible state, this device will start a countdown of 180 seconds interval or so. Okay, so 180, 179. If between this 180 down to 0, they receive heartbeats from this link, right? They are still receiving heartbeat from this link, then this node 0 is going to transition to the disabled state. Okay, so that's just the whole idea about the ineligible and disabled state. Okay, so this timer needs to run through before it gets to the disabled state. Now, once a device is in a disabled state, you can still log in to the device, but for you to bring it out from the disabled state back to the secondary, you have to do a reboot. Okay, now you can either do a manual reboot if you are aware that the device is actually in a disabled state, or first you have to fix the control link, right? Something is definitely wrong. So if this port actually flapped, went down, for like maybe 30 minutes, and then just on its own it comes back up, and this device has already transitioned to disabled state, what will happen is, if you have this command that says I think the command is set chassis cluster call it control link recovery. I think I used to call it cluster link. It's actually control link recovery. So if you have this command enabled, what happens is if this port on its own comes up, or it was fixed by the administrator or whoever is responsible for managing the device, then the moment they start receiving heartbeats over this link, then this command is going to initiate an automatic reboot of the secondary. Okay, so it's going to reboot it, and then it comes back into the secondary mode. So we're going to see if we can test it here. I can't guarantee that it will work, but let's see if it's going to work. Okay, so what we need to do is we need to first of all configure that command. Yeah, so the command is set chassis cluster, and then we're going to call it control link. Yeah, control link recovery. I think that's just the command. Okay, so here you can modify the heartbeat values. I think so. I think the default is 1000 milliseconds. Then you can also set the threshold, which we said was 3 seconds. So I'm going to hit enter, and I'm going to say commit. I don't think we need to add any additional thing to it. Commit and quit. Okay, so what we need to do now is we can come here and say let's shut the control link down now. I think it's port 00 on this lab. So I'm going to say set interface GE. So something else we can do, we can also shut it down on the switch. Let's see if that is possible. So we know that on the switch, let's go up. So on the switch, we know we are connected to port 6, right, on the switch. So let's try to break the control link on the switch level, so that it's not like I don't know if it's going to behave differently. So I'm going to console to the switch, and then let's try to, where's my console? Okay, so this is the switch. This is an Aristo switch that we're using here. Admin and enable. So I'm just going to go into interface Ethernet 6. Okay, so let's do it this way. I'm going to say show LLDP neighbors, which I think is running. Yes, so it's actually port. So we're actually learning about, let's do it from the primary. I just want to be sure that we're on the right port. So if I say show LLDP neighbors, which I think I enabled in the past, so yes, port 6 is actually yes. So this makes sense. So it's actually port 6 on the switch end. Okay, so this is the port we actually need to shut down, because what you see physically might be different what you see on the code. So I'm going to say interface Ethernet 6. I'm just going to shut it down. Okay, so it's shut down. So show chassis cluster status. So it says lost. Let's see what this says. Yeah, so it goes into the ineligible state. Okay, because now there's a countdown, so it's going to be here for 180 seconds. Okay, it's going to be in this ineligible state for 180 seconds, and if it keeps getting heartbeat on the fabric link and the control link is still not back up, then it's going to say, oh, something is obviously wrong. Okay, it's going to move into the disabled state. Okay, so most times when you see something like this, just know that, oh, the control link is broken, right? And here, see what it's telling us here, that this node is lost. So what happens on the primary? The primary will continue to be primary. It will not, go into disable. So I don't know. I was the primary when I lost him. So I can't go to secondary, because I don't know if he's actually alive or not. But the secondary, because he was secondary, is going to move to that disabled state. Okay, so 180 seconds is a lot of time. So I might need to pause the video a little bit, and then when it's back up, then we're gonna say it. So the 180 seconds ran out, and as you can see, the device have now moved to the disabled state. Okay, both for now, it cannot be disabled only for redundancy group 1. It's both for redundancy group 1 and redundancy group 0. So what we can do now is we can try to bring that port up and see if the secondary, if the link is restored, if there's going to be a reboot. So let's see. So the link is restored. Yeah, so the connection is up. This is a virtual environment, so you don't expect to get the exact result, but we'll see what happens. So they should start getting heartbeats. It should really transition from the hold state. I mean, from lost to hold. We see. Okay, I see something changing here. Yep. So that's what really happens. So as you can see, there's a reboot, automatic reboot, because we initiated the we had that command that say control is it what did we call it? Control link recovery, right? So it's going to automatically reboot because the control link is back up. Another question I had in mind was, okay, so if it moves into the ineligible state and it hasn't transitioned to the disabled state and the control link comes back up, I think what happens is going to move away from that ineligible state back to the secondary state. Okay, we could have tested that, but of course, okay. So within that interval, if the control link is restored, I think it moved back from the ineligible state back to the secondary, and everything is fine. But if it runs out of that interval and there's still no, the control link is still down, it moves into the disabled state, and you have the and once you fix the problem, you have the automatic failover. Now, one last command that I have not shown here is the show chassis cluster information. Okay, so what this is just telling you, this is going to just give you like a history of the different failover that has happened. Okay, it's like a historical information of what has happened. So you see, for redundancy group 0, look at what it's telling me. On this date, it was on hold state, moves to secondary, and you see a whole bunch of information here, right? So it tells you, this gives you if there has, so this is like a historical information, tells you there has actually been, things happening between both clusters. You also see failure information, right? Port 1 and 2 up, but it's still down because the other end is down. Yeah, so this is another command you can use to get those kind of historical information about what happens. Now I say control link failure information. It says link status monitored failed, dual control link status unsupported in this case. Yeah, so there are some, I think there are some higher end Juniper devices that you can have redundant control link, so that if one fails, the other one is still up, right? I think XR5 something. There's some hardwares that support that, but in our own lab we can only use one device. So this is still telling us that the control link is down, and if you give it some time, it's going to put back up and everything is going to be fine. So thank you so much for this video. The next thing we need to look at, there's still something less we need to do, but of course not in this video, is we now need to look at so now our focus is these connections, right? Is what we are monitoring. Now what if these connections are actually fine, right? But somehow, right, we could have two links, right, that goes to the internet, okay, from here. So you have this, you have this. Okay, so maybe somehow this traffic goes through this path, and this path ends up being broken. Okay, so what we can do is we can also enable what we call IP monitoring. Okay, so we can be pinging the gateway on the internet. So the service provider is going to have a device here. We can do a continuous ping to this device. So we will say, at any point, if the primary cannot reach this device, this IP here, go ahead and, so if the primary cannot reach this IP, but the secondary can reach the IP, go ahead and do a failover to the secondary. Okay, that is what we can achieve with IP monitoring. So it goes beyond the interface status, because if you can't reach this IP, there's a routing problem, but these interfaces are up, you're going to have problem, right? It's going to result in black hole, traffic black hole. So we can be tracking not just one IP, we can be tracking as many as 64 IPs, okay? 64 IPs pool on the internet with a cumulative value of weight. So we're going to talk about that in the next video. So let's not get into too much details. So we're going to look at how we can actually enhance, this failover mechanism by also tracking IPs on the internet from both servers. Then we're going to go into details, okay, what actually happens to the IPs, because remember the IPs here are the same. So how is he able to ping the internet? When the traffic comes back, how do we know if this guy should respond, if this guy should respond? Because the secondary is going to also be pinging, the primary will be pinging. So are they going to be using the same IP? Would they need to be using different IPs? Are they going to be using the MAC address on the direct interface, on the physical interface? So we're going to discuss those details in the next video. So thank you so much. So if you like this video and you want to be able to see more videos like this, you want to subscribe, you want to like, you want to also share with your colleagues and your workplace. Okay, thank you, and then see you in the next video. Bye.